This is a screencast for section 9.45a, example 7. The nth root test is not exactly something your book presents to you other than a little box in your exercises and a couple questions on it, but I think it's a valuable test to know in our bank of tests that we're using to show if the sum of a series is convergent or divergent. This test is great for any series to an nth power because basically you're going to take the nth root and find the limit, and then the outputs are very similar, the outcomes are very similar to the ratio test. If your limit is less than 1, the series converges, greater than 1, it diverges, and equals 1, it's inconclusive. So we'll take a look at one of the exercises, number 73, and from 9.4, and look at A as our example and B as our now try. A is asking to find if the convergence or divergence of this series right here, and I see I have 2 to the nth power in the denominator. Interestingly enough, the ratio test example had one very similar, n squared minus 1 over 2 to the nth power. So we already know that this converges. We just want to show a very similar situation in a different way. We wouldn't have been able to use the nth root test on this example because of the minus 1 there, but now we can. So I'm going to take the limit as n approaches infinity of the nth root of the absolute value of my series. Now, all of our n's are positive anyway, so I don't have to worry about that absolute value so much. It's just mostly for show at this point, but you do want to show that. In the numerator, I'm going to separate the nth root of n squared, and I'm going to make that the nth root of n squared because of this little hint up here. The limit as n approaches infinity of the nth root of n equals 1. That's going to come in handy. Then the denominator, I'm going to take the nth root of 2 to the n. Well, that numerator, since that limit here is 1, we're really dealing with 1 squared in the numerator, and then the nth root of 2 to the nth is just 2, because the nth power and nth root are inverses of each other. So I have 2, which is 1/2, and that is in fact less than 1. So by the root test, this series converges. The now try problem, part B. I have this nth power of the whole thing, so that is just screaming nth root test to me. So I'm going to take the nth power of the absolute value of this whole series. Again, the absolute value are irrelevant because n is just positive anyway. It's going from 1 to infinity. And as n does approach infinity, the nth root and the nth power, they cancel each other out. So as n approaches infinity, I get infinity over infinity, use L'Hopital's, and I have 1/2, or that's just a basic limit that simplifies either way. And that's less than 1. So again, by the root test, the nth root test, this series converges.